All right, hello, ladies and gentlemen. This is section 6.2, transforming and combining random variables. You're going to need a graphing calculator. So if you don't have one, please grab one. And let's begin. All right, here's what we're going to talk about. We're going to talk about the Comfy. Okay, the Comfy is an item that was on Shark Tank about 3 years ago, and it is a blanket that looks like a sweatshirt. Okay, don't believe me? Google it. You'll see what it's like. You're going to want one. All right, it did so well on Shark Tank that was on QVC numerous times after that. It's been in Costco, it's been in Sam's Club, it's been in Walmart, it's been in Target, you name it, it's been there, all right? And they've sold lots and lots and lots of them, and the organization is doing very well, okay? They're also being sold on Amazon, all right? And Amazon loves this product, and they can sell these at a very high rate, but for a very reasonable cost, okay? Above this little paragraph, you'll see there's a probability distribution for how many they sell per day and the respective probabilities for each of those days, okay? Each of those amounts. So on some days they sell 150, sometimes 160, 170, and so on, and those again are the respective probabilities, all right? I'm asking if you would find the mean and the standard deviation for the amount of companies sold on Amazon per day, okay? Now, if you don't remember what the mean and standard deviation is represented by with respect to a formula, there you go, okay? Remember, we typically put these in L1 and L2 from 6-1, okay? And what I'd like you to do is take a moment on your own, pause this video, put those in L1 and L2, and find for me, if you don't mind, the mu sub x and the standard deviation of x, okay? That is from our previous lesson. You got to remember how to do that, okay? And I'm going to show you how we'll use it on our next slide, okay? So hit pause for me if you don't mind, okay? Give this a shot, and we'll talk in a moment when you have calculations for each. All right, if you did that, okay, here is the average for X, okay, which is the number of comfies sold per day on Amazon, 177.5, and the standard deviation is 13.369. Okay, so on average, again, we expect to sell about 177.5 comfies per day through Amazon. And the 13.369 means that, you know what, sometimes we'll sell a little bit more, sometimes a little bit less, but on average, okay, the amount of comfies sold per day will vary by 13.369 comfies from the mean amount, okay? Now, here's what Amazon's doing, and this won't surprise you. They're giving free shipping to all their customers for those who buy a comfy. No surprise, Amazon does that. However, that doesn't mean it's just free in general, okay? It means that someone else is gonna have to pay for the shipping, and it's going to be this group, the Comfy. I'm highlighting them right here. The Comfy's gonna have to pay for it. And here's what Amazon's gonna charge them. They're gonna charge them a daily shipping rate of 20 bucks just to pick up the orders. Okay, so just to bring a truck by, okay, to the warehouse just to pick them up is $20, okay? And then they're gonna charge $3 per comfy. Okay, and here's what I'm gonna ask you to do. I'm gonna ask you to create an equation for the average cost, okay? So let me highlight that, the average cost for the daily shipment, okay? And we'll label that with a mu sub y. And then I'm also gonna ask you to find the standard deviation for that average cost for all that shipping, okay? Now, formula that I'm giving you starts down here, and I've already defined mu sub y. That's actually in there. Mu sub y is the average. Let me just write it over here. Average shipping cost, okay, per day. Okay, and again, comfy organization is going to have to pay for that. And mu sub x, we've already defined from the previous side, that is the average sales per day. Okay. Now, if I want to know the average cost, I have to be able to make an equation. Okay. And so this average cost, which is mu sub y, and again, that's the average cost for shipping, is A plus B times the average amount sold, at least through Amazon. All right. Now, one thing we know, we said this earlier, is that there is a daily shipping rate of $20 just to pick up the orders, okay? Regardless of how many we're actually sold that need to be delivered, and that is $20. You will find that sometimes there is no flat rate for something, and you don't have to worry about that piece. It'll just be a zero. Okay, so don't always expect there to be a flat rate for something. They do exist, but not always. Okay. Second part is, what are you charging per comfy? All right, and we are charging $30 per comfy. Okay, and I'm just going to say 3 times use of x. Okay, now here's the deal. If I want to figure out the average cost per day that's being given to the comfy for all their shipping, I have to know how many comfies are sold on average through Amazon. Okay, and do we know what that is? Yes, we do know what that is because you found that just a few seconds ago. All right, the average number of comfies sold per day through Amazon is 177.5. So I'm going to write that here. I'm going to say use of y is equal to 20 plus 3 times 177.5. All right, and you are allowed to use your graphing calculator to figure this out. That's why I had you take one out to begin with. And if you do all your math right, you should get 552.5. And I'll put a 0 behind there because we are talking about money. And what does that mean? It means on average, okay, the shipping cost will be $552.20. Okay, and I'm going to add something. I just said the shipping cost. I call it the daily shipping cost. I'll put that above. Okay, for the comfy. Okay, and I could also say by Amazon, but I'm just going to leave it at that, just not to make it sound so wordy. Okay. Now, is that a guarantee that every day it's going to be $552.50? No, some days will be higher, some days will be lower. And because that is variable, that means there is a standard deviation associated with this average. Okay. Now remember, standard deviation is only influenced by products. It is not influenced by addition. Okay, so for example, just to remind you, I'm going to put this in, how about a different color here? How about green? Let me just take these numbers. I'll put it up on this top right-hand corner. If I take just the sample of numbers, 1, 2, 3, 4, 5. Okay, and if I add the same number to it, like say 10, and get these new numbers, okay, the variability with the first group is the same variability that you would see with the second group, meaning, kind of in layman's terms, the spacing that you have with these numbers 1 through 5 has a similar spacing, actually an exact type of spacing that the numbers 11 through 15 have here. Okay, so the idea is that if you're adding a flat rate of $20 for every order, that $20 doesn't make your shipping costs any more variable. Okay, if they're always charged $20 regardless of how many they have, it's not influential in terms of a standard deviation. Okay, because it's not showing an increased gap. Okay, for each of the orders based off that 20 bucks. Okay, if everybody's charged it, okay, then it kind of it's taken out of the picture when you're considering variability. Okay, now the formula that I'm giving you here, okay, is actually, it's not one that's in the book. It's kind of like my own version of it, but I think it's pretty easy. And it basically says the same thing. It's the standard deviation of your shipping cost, of the number sold, which is right down here, 13.369. Okay, times the rates, okay, that they're charging you for per comfy. And in this case, it's the absolute value of the same B that we had before, which is 3. Okay, so you can write it like that. The book will do it a little bit differently, but this is the way that I'm most comfortable with. The absolute value of 3 is 3, and 3 times 13.369 is 40.107. Okay, and so what does that mean? Okay, it means that the shipping cost, okay, will vary on average, okay, by 40.11, I'll just round it because we're talking about money, $40.11 from the shipping need. Okay, so it's not always going to be $552.50 to ship your items. Sometimes it'll be a little bit more, sometimes a little bit less, but on average, for each day that you're shipping something, it will vary by about $40.11. Okay, I'll put that in there too, per day, each day. Okay, and there's really not much else to this other than what we've written. Okay, half of your work in this will resemble what we just did here. I'm going to put a different color here just for a second. I'm going to put this in purple. Just for your awareness, and I'll go above here. Sometimes they're not going to use, for example, I'm going back down, use of Y. What they'll use is instead is just a plain capital Y. Okay, and sometimes they won't use a use of X. They'll just use a big X like that. And just know that each of the representations are the same thing. Okay, you can use these interchangeably. You can use a use of X or a big capital X or a use of Y or a big capital Y. Totally up to you. Okay. All right. Last problem, new problem that has many little questions on it, but it's easy stuff. Okay. Here's what I got. It says the following teachers have the given 1 mile running averages and their respective standard deviations. Okay, so these are the respective teachers in the math department, okay, at the school that I work at. And you can see there are 4 of them, and there are 4 average mile times that each of them have, and 4 respective standard deviations. Okay, now they're going to do one of these big races where they each take a part and they each have to run their own mile. Okay, so it's going to be a collective 4-mile run, 4-mile team run. Okay, again, where each mile is run by a different person. Here's what I want to know. What is the team average and standard deviation, okay, for all 4 members? Okay, so for example, if the first mile is run by Dominguez, I'll just put a D there, and the second mile, okay, second mile is run by Lowry, I'll put an L there, and the third mile is run by Figueroa, and the last mile is run by myself. Okay, and you know, are all the mile times going to be the same from trial to trial? No, this Dominguez's mile times are maybe a little bit slower, faster, depending on the day. Same thing with Lowry's, same thing with Figueroa's, same thing with myself. What I want to know is what is the collective average time of the 4 of us? Now, when I say average, it's not the average 1 mile time, it's the average 4-mile time, because we're doing a 4-mile race, okay, the collective average. Okay, and this seems like a super intense problem, but it's actually pretty easy, okay? And let me write this in a different color so you can see this a little bit more easily. And here's the idea. If I want to know the average of this team time, which includes Dominguez and Lowry and Figueroa and myself, then all you do is you do the individual averages per person. Okay, and so I'm going to input just those numbers in. 8, 7, 9, and 10. Okay, and if you add these all up, it looks like you get 15 plus another 9 plus another 10. Looks like 34 miles or 34 minutes. Okay, so that would be our respective team time. Okay, make sure my math is right. 19 plus 7 is 26. 34 minutes. Okay, so are we going to be a little bit faster sometimes? Sure. Will we be a little bit slower sometimes? Yes, but on average, our 4-mile time should be on average 34 minutes. Okay, Now, for every average, there will be a standard deviation because, again, we're not going to hit 34 minutes every single time. In the formula for the standard deviation is going to be a little bit different, okay? If I want the standard deviation for, again, all 4 of these people, okay, then you're going to have something that my students like to call something Pythagorean theorem-like, okay? And what you're going to do is you'll take Dominguez's standard deviation and square it. And then you're going to find Lowry's standard deviation and square it. And you're going to do this with each of the respective standard deviations. Okay, and there'll be 4 of them. Okay, and so since we were given this information, okay, we'll take this 1.2 and square it. And then we'll take 1.3 and square it. And then we'll take 1.6, these are all the standard deviations I have here, and square it. And we'll take 1.8 and square it. Okay, so I'll do that as well. 1.2 square it plus 1.3 squared plus 1.6 squared plus 1.8 squared. Okay, and if you put it in your graphing calculator as I did, okay, you should get 8.93, okay, underneath my square root bar. The 8.93 by itself is the standard deviation squared, which is really just the variance, okay? And then if you square root this answer, and I'll do that right now, the square root of 8.93 gives you 2.99. Okay, and what does that mean? I like to write out my standard deviations, okay? On average, the team time for a 4-mile race will vary by 2.99 minutes, okay, from the mean. Okay, so sometimes it'll be a little bit slower, sometimes a little bit faster, sometimes a lot slower, a lot faster, but on average, we should be about 3 minutes away from this 34, okay? And there you go, okay? Now, here's the deal. Sometimes you're not gonna have 4 items to be part of your work. Sometimes there's only 3, and that would mean that you would only add up 3 things, okay? Or maybe you'd only have 3 items in your standard deviation, and you wouldn't include a 4th, I'll say term within your square root, okay? So think about how many items that you have that are making your collection, your total collection, and make sure you just represent those accordingly within your standard deviation underneath your square root bar, or within your average, just adding those together, okay? All right, now let me build on this a little bit, because sometimes we will have 4 items like we have here. Sometimes we will not, all right? So same information, but let me have a little bit different perspective here. It says, if Mr. Rothery and Mr. Lowry are running a 2-man race where each athlete runs 1 mile, what would the team average be? Okay, so not too hard. This is just Lowry plus Rothery, and his average plus my average will just be looked at. So his average is 7. You can see he's much faster than myself, and my average is 10 minutes, and so that gives us an average of a 17-minute mile for our combined race. Okay. Now, what would the sum of the standard deviations be? All right, now that's probably not going to surprise you. It's the same thing as before, except that instead of having 4 items, you have 2. And so I'm just going to take the standard deviation of Lowry squared plus the standard deviation of myself squared, and then I'll square root that. Okay, so this becomes 1.3 squared plus 1.8 squared. Right, so again, a moment where you can put this in your calculator. 1.3 squared plus 1.8 squared gives us 4.93. And again, remember 4.93 by itself is just the variance, okay? But if you were to ask for the standard deviation, we would square root this answer, and you would end up with 2.22. Okay, and I'm not going to write this out because I know you're probably sick of doing this, but I'll just verbally tell you what it is, and you can write it if you want. What this will say is, I know on average that we have about a 17 minutes run for our two-man race, and sometimes it'll be a little faster, sometimes it'll be a little bit slower, but on average, okay, our 2 mile time will vary by about 2.2 minutes from the mean. Okay, on average, our 2 mile time will vary by 2.22 minutes from the mean of 17. Okay. Now, given that, again, you'll notice that we only had 2 items versus the 4. You can have as many as they give you. Sometimes they'll say we have 18 people, okay? You just put 18 standard deviations in there, square them, add them up, okay, and treat it the same way. But you'll notice that they all are sums, okay? And I have this highlighted in gold, okay? And you'll notice I have the exact same question with difference. Okay, now, if it's difference, many of you are thinking this, and I probably have to do mine first because I have the bigger standard deviation. So let's just say R minus L. Okay. Now here's the deal. If it's a difference, what you're going to do is you're actually going to write the same thing if it were an addition. Okay, so know that difference may sound like or make you feel like you need to subtract, okay, but actually it's an addition. Okay, so big error for some because they interpret it as the signal, the sign you would suggest maybe. Difference means subtract. You can write it like this, but in the end, when you use your formula, you will add. Okay, and so it just gives you the same thing. Okay, and this ends up being 2.22. Okay, last part goes like this. It says if Mr. Rothery felt Mr. Rothery was too slow and elected to run the 2 mile race by himself, what would his 2 mile average be, assuming his individual 1 mile races would be independent of one another? Okay, and this will actually appear as much as any of the other previous problems. Moments where someone is just repeating the same value over and over again. Okay, and I'm going to fit this part here. Hopefully it'll show over this little purple bubble here. But this is mu of Lowry for the first mile, and then Lowry for the second mile. Okay, and all that means is you're just going to write it twice. Okay, and so his average was 7 for the first mile and 7 for the second. We'll assume that he does not slow down. We're saying that they are independent. That is given, and that gives you 14. Okay, so on average, he'll have a 14-minute mile if you were to do it by himself. Okay, look for that type of work because they often will do that. Instead of using varying people or varying items to give different data for, sometimes they'll use the same piece of data and just have it repeat often within the same problem. Okay, and you'll just do that. You'll just add it to itself or use that standard deviation multiple times with underneath the root bar with squareds to answer that type of question as well. Okay. All right, here's the homework I'm giving you. You have both of these types of problems, this one and the one related to the Comfy. Use this as a good reference because you'll see this type of work quite often. Okay. Hope you have a good night or a good day, and we'll talk to you again soon.